Hi everyone, welcome back to our channel. Today we are going to discuss about the parallel connection of coupled coils. What is meant by an coupled coil? Okay, so coupled coil means these two coils are connected together. So these two coils are connected together, then those coils are called as coupled coils. Now how to connect them in parallel? So it's very simple to understand, but a little bit derivation is there. So now we are going to find the derivation part. So remember, we need to get the parallel connection of coupled coils in parallel additive and parallel subtractive is L1 L2 minus m square divided by L1 plus L2 minus 2m. So this denominator will be changing. Okay, so we have in this parallel connection two connections are there is one is first one is parallel additive, next one is parallel subtractive. So in parallel additive, you will get the same derivation, and in subtractive, just only the denominator will change as L1 L2 minus m square divided by L1 plus L2 plus 2m. So this is only the change what we can see there. Okay, let us try to see in detail. So coming to here, so here to draw the circuit, I am taking two inductors are in parallel. Okay, so this is inductor 1 and this is another inductor which are connected in parallel. So these are connected in parallel. Applying a voltage of V volts, a current of I amps starts traveling. So the current in this branch, I'm going to write down it as I1. So now just for understanding, I am changing the color of this inductor. So this is the second coil. So the current in this branch is I2. The value of this inductor is L1. The value of inductor is L2. So now let's try to do the derivation part. So let's try to apply Kirchhoff's current law at the node. So when you apply the Kirchhoff's current law, entering current I is equal to I1 plus I2. Okay, so from here you can write down the differential form di by dt, differentiating both sides is di1 by dt plus di2 by dt. Now let us try to find out what are the possible combinations of di by dt by intersubstituting each other. So you can see here in an parallel circuit the voltage is same. So this is an parallel voltage. We can write down the total V is equal to, and this V we can write down it as V is equal to uh, first one. What is the inductance? Here to understand I am marking the dots. So here it is entering the dot and here is also entering the dot. You can see here the current I1 is entering the dot. Here the current I2 is also entering the dot. So I can say dots are there at the entering of the currents. Dots are there at entering of the currents. Now what to do? So now the total applied voltage V is equal to, and you can see here these two inductors as an mutual inductance of M. So voltage V is equal to, what is the voltage across an inductor? The formula for voltage across the inductor V equal to L di by dt. So now from that we can write down, so the inductance of this coil is V equal to L d I1 divided by dt, and it is associated with mutual inductance of the another coil with a value of m. So that we are going to write down it as plus m into this mutual inductance inductance is due to the current I2, which is dI2 divided by dt. So how to write down with polarities, and you can see here I'm writing in the form of KCL. Voltage sources is equal to voltage drops. So voltage source is how much? V, and the drop is nothing but L di by dt, and here the drop is due to I1 current. Here the drop, mutual inductance drop, is due to the current I2. So this V is once again, the voltage is same across the inductor too. I can write down this as V equal to L2, current in the second inductor is d I2 divided by dt, and it has a mutual inductance of M due to first coil. So I can write on it as d I1 divided by dt. So now on our average both are same, and this V is also is equal to L equivalent di by dt. So we want to find out our answer, which is L equivalent. This is the value what we need to find out. So for this we have two equations. Now let's try to intersubstitute each equation. So let us try to consider only these two equations now. So from these two equations I am taking di1 as an common term, equalizing that. So di1 by dt is equal to L1 minus M, and from these two equations I am taking di2 by dt as an common term. Therefore I am going to get L2 minus M. So now I am writing in the form of di1 by dt. So the value of di1 by dt is equal to di2 divided by dt into L2 minus M divided by L1 minus M is the value of di1 by dt. So now let us see that we will see an equation only in terms of I2. So here I am now writing the equation of di by dt. Therefore, di by dt is equal to, substitute the value here, di by dt in terms of di by dt. So this I can write on it as di2 divided by dt into L2 minus M divided by L1 minus M is our equation. Plus, what is the second term? We have d I2 divided by dt. So now this is what the ultimate equation we have. So ultimate I can write down di by dt, where this is equal to, by taking di2 by d2 as an common term, which is di2 divided by dt is equal to L2 minus M divided by L1 minus M plus 1. So this is the one of the major equation what we have. Okay, let us try to assume this is first equation, and already we had seen that voltage V is equal to L equivalent di by dt. So V is equal to L equivalent di by dt. Okay, so now let's try to substitute the value of, but the value of V is this one. Okay, so now I can write down L equivalent di by dt is equal to, I'm using this equation for V. What is the value of V? Which is L1 di1 by dt plus M into di2 by dt. So this is the second equation. Now see that I require an equation only in terms of I2 only. So I will try to intersubstitute in the name of di by dt. So I want the expression of di by dt is equal to 1 by L equivalent of, so L1 into di by dt. So L1 into di1 by dt plus M into di2 by dt. So here I want to express I1 in terms of only I2. Substitute di1 by dt in terms of I2. So therefore I can write down di by dt is equal to 1 by L equivalent of L1 into I2 by dt of L2 minus M divided by L1 minus M plus M into di2 divided by dt. This is the ultimate equation. So now mm, let us try to segregate it and write down. So in this di2 by d2 is a common term. So I am writing di by dt is equal to 1 by L equivalent, and I am taking di2 by dt as an common term, which is L1 into L2 minus M divided by L1 minus M plus M. So let us try to mark this is the equation of di by dt only in terms of I2. Okay, so this is equation number 2, equalizing first equation as well as second equation commonly. So therefore we are going to get the formula for the parallel connection of inductance. So here is substituting each other. So di2 divided by dt into L2 minus M divided by L1 minus M plus 1. So when you take plus 1 as common, this is L1 minus M. I'm taking this L1 minus M as an LCM part, that is equal to, so here I'm writing 1 by L equivalent of di2 divided by dt into L1 L2 minus L1M plus M into L1 minus M divided by L1 minus M. I'm taking it like an LCM. And now you can see here L1 minus M, L1 minus M will get cancelled, di2 by will get cancelled. So here we will get L1 plus L2 minus 2M is equal to L1 L2 minus L1M plus ML1 minus M square. So these two will get cancelled, which is 1 by L equivalent. Therefore L equivalent is equal to L1 L2 minus M square divided by L1 plus L2 minus 2M is the value of L equivalent whenever they are connected in parallel and when currents are both entering. So here you can see here whenever the currents are entering, this is what the value you have been got. So in the circuit you can see here these two inductors are in parallel, and here the current I flows. I1 current is entering the dot, I2 current is also entering, then this is the formula. So similarly I can call this circuit as parallel additive. Then this is the resultant, and you may get the same formula. You can write down this also in one more format. This is inductor 1, this is another inductor. A current of I1 is flowing like this, a current of I2 is flowing like this, and dots are available at these points. You can see here for the both the currents are leaving, then also I can call them as parallel additive, and the formula for this is L1 L2 minus M squared divided by L1 plus L2 minus 2M, and for the same you can do here, which is called parallel subtractive. For parallel subtractive, it's very simple to understand. So I have an inductor, this is inductor 1, this is one more inductor. So here the current in the branch is I1, here the current in the branch is I1. A dot is there at entering and one dot is there at leaving. I can call this as parallel subtractive. The L equivalent for this circuit will be L1 L2 M square, the numerator remains same, divided by L1 plus L2. So here I can write on this as plus 2M. So here current is entering the dot and current is leaving the dot. The same I can draw one more circuit. So here I have a dot and here I have a dot. So for the current I1, this is laid at the dot is there at leaving. For the current I2, the dot is there at entering. This is also called parallel subtractive. Therefore, the formula of L equivalent is L1 L2 minus M square divided by L1 plus L2 plus 2M. So remember, these are the four possible combinations we can create in the case of an parallel, in the case of an parallel additive as well as parallel subtractive. Both the currents are entering L1 plus L1 L2 minus M square divided by L1 plus L2 minus 2M. Both the currents are leaving the dot, same formula. So for one coil current is entering, for another coil current is entering, current is leaving. For this current is leaving the dot and current is entering the dot, which is also called parallel subtractive. In parallel additive, the flux is additive in nature. I mean, the flux get added itself. I mean, it is like additive nature. In parallel subtractive, flux is opposing each other. The flux opposes each other. I mean, phi 1, phi 2 both are opposing in this case. Here, phi 1, phi 2 are additive in nature. Hope the content is very clear. This is all about the parallel connection of coupled coils which are connected together. Is how the network operates. Hope the content is very clear. If you want, just what you have to do is write down the voltage equation and express the di by dt in terms of only I2. Express di by dt only in terms of I2, and you can see here just equalize, then you'll get the formula for parallel additive, parallel subtractive. Here currents are here currents are entering the dots or leaving the dots, but here one current is entering the dot and one current is leaving the dot. So if you feel the content is useful to you, please like the video and share with your friends. And if you have any doubts, let me know in comment section. And if you are watching for the first time, subscribe the channel. This is a free channel for the development of students and faculty. Yours obediently, Ram.